We are live. Yes, we are. Let's just say outside noise is at minimum, or it is. Let's just hope that it is not being captured right now. Okay, seems like it. The fuck? Ah, bro. Ah, this does work. Nice. Today, today, today. Hello, boys. Today we are going doing this thing. This MQTT. This MQTT. So in the last stream, I did something, but I did not push. I never actually, I never streamed. And this is not event bus. This is for MQTT implementation. This is not event bus. Language it is. Cool. So this guy, whoever this is, wrote some blog, which is which is very good for me because I always look for these blogs to implement raw protocols. MQTT seems like really good to me. It's designed to be lightweight and it's designed to be a design pattern which is particularly interesting to me or for me. Mean to say I'm very interested in this design pattern. That design pattern is pub/sub. Pub/sub. I always feel like the polling doesn't make sense to me. There are instances which requires you to have poll. Okay, so we'll go through this. So I think I did this header. I copied this here. So I have this MQTT header. So let's just try to understand because I forgot what I did before. So if I have to make sense, some structures, some union, some enum. Okay, enum as well. So you're saying that MQTT header is a union, and why is that? Because I just try to make sense from there. MQTT header is a union. This guy is the byte one. So if I look at this, let me bring my mouse. Wait. This is fucking exciting, man. I just don't know what it is, but I can understand why people stream. Even the people like, did you know Prime just Prime quit from his Netflix job? Bro, that's some bold decision. For a second, I was thinking, how can it do that? It what has to be the circumstances under which someone could quit almost $1 million job, and he quit it for streaming. I guess it is right that after a certain point, money becomes least of your worries. But right now I need money, a lot of money, shitload of money. Okay, so let's just try to make sense what this thing is. Like, why would I need union? Struct I can make sense, but union, I never used union before, but I know the concept behind unions. So let's try to break it down today. It is 21, like 9:30 करीब. It's 9:30. We'll keep it on our stream because now like this. So saying, yeah, if I have to model this by myself, then I would go with the struct of this many bytes in this base memory. Okay, so I'm thinking union is, if I make this union, see, let's see what is happening right here. It creates a union. It's a byte, and then you obviously creating a struct. What is this? A struct that belongs to this. It's an unnamed struct. This syntax is making me sick. Struct. Can I ask ChatGPT, like, what is this syntax? Explain this syntax. See, I program in C for a living and I don't know this. Define C structure with the bit fields. Let's break it on. Struct keyword is string. This is the data type representing a 8-bit. Bro, that is not what I want. Purpose of using bit fields like this can conserve memory by Python, blah blah blah. Is this anonymous struct? No, the struct in this percentage is not anonymous. An anonymous struct in C is a struct without a tag name. In the given syntax, the struct is not anonymous because it has a name. Here's the example of an anonymous struct. But it is anonymous, bro. If in this example, the struct is anonymous because it doesn't have a tag name, because it's typed as point. The struct in the provided syntax lacks a tag name and isn't typed with it, therefore it. Kabhi sala, what is anonymous struct in C? This approach is specifically useful in embedded systems where configuration settings are often numerous and diverse. Here is an example demonstration how you might define a configuration structure for hypothetical devices and anonymous structure. So these are anonymous structures. This is because I remember if you put this before a semicolon, where did it go? If you put a name before this semicolon, then this becomes a variable declaration or definition, whatever, but it ain't a structure's name. See, because the thing is, if I'm doing type def, if I remove this, and then this becomes type def struct parenthesis, and then hold this thing. So hold this thing will be anonymous struct if I remove this. So what I'm doing is I'm type defing this anonymous struct with this name. Okay, so this is anonymous. It just bits is just a declaration of this struct, like variable declare when we declare variable. Okay, I don't need to go deep into that. Just take it on the face value. We are doing something right. Seems good to me. So it's either this byte or this much memory. This much memory is nothing but a byte because 4, 5, 6, 7, 8. It's an 8-bit. What did ChatGPT said about it? ChatGPT says you retain 1 QS2, duplicate 1 for 2. These are the bit fields within the structure. Bit fields. They specify how many bits each variable will occupy in memory, starting from where. That is the question I want to answer. I want to have an answer. These are variable names. 1 to 1 for specify the number of bits each variable occupy. Indicates that the variable will occupy 1 bit, 2 bits, 4 bits. I'm guessing from the start I can do this. These are the flags, like retain flags and all of that. Retain flag must be retained in the words. The first, so I have to bring the official documentation, huh? Yeah, boy. Data representation. TTT control packet. It has to be added. There has to be some sort of header. These are defining control panel. That mute was necessary. Terminology, TTT packet format, fixed header, or flags. There. These 4 bits are good control packet bit byte 1 bit 7 4. Position is byte 1. Control packet types. Control packet, these are the control packet types. Then the flags, the remaining bits 0 to 3, 3 to 0, 0 to 0, however you get it. of byte 1 in the fixed header contains flag specific to each MQTT control packet type listed in table 2.2. Where the flag is a if the control packet type is published, then this flag will be set. So bit 0 will be retained. I don't understand. Dope QoS retain. So first is written, so let's just make sense this, like if this is written, then start from initial memory. That means this this one is written. So when I say retain takes 1 bit, that means it's going to take the initial this bit. Then QoS is 2 bits. Next 2 bits are for QoS. And 4, 5, 6, 7, 8. It's a freaking byte. That is why it's a union, bro. I mean, if the packet type is there, then these are also going to be there. What I don't understand is this combined makes 1 byte. This whole thing is 1 byte. So the maximum memory this union will have is 1 byte. Oh, okay, my bad. So this just defines that there is going to be 1 byte. Either I can access this 1 byte as a byte, or I can access by their bit names. These are the names that I provided those bits. So the retain is 1 bit. This is 2 bits, 1 bit and 4 bit. So what happens is this: if a flag comes, it depends on what the value of this thing is. No, I'm not understanding this properly. MQTT header, that's a union. Now fuck, it's going to be a separate connect, bro. If it's a separate connect, then its value is 1, which I think here its value is 1, and is there any flag? When it's a connect, then fixed header flags. Fixed header is what? This fixed header format is this. This is result. I understand. See, the value is just 1. So it will just be placed in in here. In that case, in case of connect control packet, these bits are going to be 0. Fixed header flags. Fixed header flag is reserved, and all of these bits are 0. In that case, this 1 is going to be here. This bit is going to be 1. For connection acknowledgement, it is 2. In this case, the flags bits are 0, so the 4th bit, this one, is going to be 0, and this is going to be 1 because there's a 2. Similarly, in this publish used in MQTT 3.1, whatever the value that MQTT 3.1 has, it is going to be that. No, I'm messed up today, bro. It's going to be 3. This going to be 3. This, let's see, it's going to be one of those. So 3 means I have 2 and 1, 3. So these 2 bits are set. How do you implement it, bro? You are not going to make each struct. This is some wizardry going on. तो पढ़ना पड़ेगा भाई, इसके बिना नहीं समझ में आने वाला है. Okay, so fixed header part. मेरे तो ना रहे हैं, बूढ़े हो रहे हैं. Fixed header mandatory, everything is optional. Got it. Flags are not mandatory, just a 4-bit MQTT control type and the other. Duplicate flag used when a message is sent more than once. Are these flags mutually exclusive? These ones, are these mutually exclusive? I don't know. Chat. There is no chat. Full screen. Written flag if a message, it's a bit ठीक है. That's good. These value will be coming from here, I guess. 0 to 15. Disconnect reserved, 15 is reserved, fine. QoS is 12012. Reload. Connect 3.1. Three point two. Publish. I think there is some mistake. This has to be 1, or I'm reading it wrong. Retain QoS duplicate. These are all these 3 values, right? Retain QoS and duplicate. Yeah, this is some extra thing. Holy fuck. Got it. These are the 3 things. This is for the 4 bits, last 4 bits. This one, 4 bits. It's complete. I'm just so stupid, man. So stupid. How can I miss this? Like, these are the only 3 properties. Makes sense. Either I access it as a byte or I access it by the individual field. The type will tell me what is the packet type, one of those, and this will like some attribute assigned with one of those or more than one of those. Got it. Now what happens when I have MQTT connect? This packet will have a header, which is this, which is just a byte, and then I have a union, and then I have a struct. So I have a payload, and I have God knows what. That's anonymous. So the union is of either it's a byte or these are bits. So it's basically a byte. So 1 byte, 2 byte, and whatever bytes these are. This whole thing is a 2 byte. Then this is 2 byte pointer. I'm guessing 4, 2, 3, 4, 5, 20, 22 bytes, 24. So this whole thing is 24 bytes. Let's say what it does. Okay, I think we all have a feel, right? Right, brother. Where did he get these values? I mean, he implemented the whole thing, so that's how he got it. You tell me a little. Let's see. The first 2 has defines refers to fixed size of MQTT fixed header. First 2 defines MQTT header length, acknowledge length, fixed sizes of MQTT fixed header, and of every type of MQTT packet. So egg packet will have size of 4 bytes and header will have size 2. Every header, fixed header. How is it 2 again? Because that is 1 byte. This is just gold, man. This is just gold. Because I can simply give names to bits, bro. Do you understand? I can give names to bits. I would say some MQTT header dot, let's just say h, and then I would say h dot byte will give me this complete byte, right? I can access it as byte and operate on it. Or if I need certain bit information, let's just say I want to read a particular bit, in that case I would call that h dot retain. It will literally give me, sorry, h dot bits dot this retain, h dot bits dot retain, h dot bits dot qos will give me 2 bits of information. You see how powerful this is? Why don't people do that often? I mean, I never did it. I never implemented thing. That's why that's why this protocol implementation is just so good, man. Because the first thing is they just define everything for efficiency. Like some entity has defined these standards, so they obviously iterated on these standards, and after iteration they come up with these values so that they are efficient. And if you implement these things, they just become super interesting. And people who write these kind of blogs just makes your life easy. You get all the information. Things get abstracted, but it's a good, very good starting point. See, okay. I shouldn't be leverage the union will represent within the same position in memory to represent the wider bit fields. First control packet we are going to define is connect. It's the first packet that must be sent when a client establish a new connection, and it must be exactly 1. More than 1 connect per client. More than 1 connect per client. What does that mean? More than 1 connect per client. Okay, so once a client is connected, it can't send another connect. It can send another connect if the first connect somehow didn't reach the server. In that case, from server's point of view, it is the first connect. But after the connection, it's okay. Must be treated as a violation of protocol and the client must be dropped. For each connect, a connect packet must be sent in response. What if client drops this connect? So MQTT connect. Why am I differentiating things? Because I don't want to say it. So it is going to have a header. Does it? 3.1 packets connect. Client requires a connection to a server. The server must process a second connect packet sent from a connect as a protocol violation, and this connect the payload contains 1 or more encoded fields. They specify a unique client identifier for the client, a will topic, will message, username, and password. All but the client identifiers are optional, and their presence is determined based on flags in the variable header. .1.1 fixed header. Connect packet fixed header is going to be of 1 byte, which is, see, it's 1 because these are reserved, so they are 0. This is 1. Remaining length, what goes into remaining length? I don't know. Okay, so it's a variable header, so maybe the remaining bytes coming, I don't know. Remaining length field, remaining length is the length of the variable header, 10 bytes. Variable header, length of variable header. If it's a variable, how is it a header? Plus the length of the payload. It is encoded in the manner described in section 233. Some type of MQTT control packet contains a variable header component. Structure of MQTT control packet. Fixed header present in all MQTT control packets. Variable header present in some MQTT control packets. Payload present in some MQTT control packet. So I have designed this MQTT connect. It's a type of control packet, right? Yeah, packet type control. It's going to have a header. It's going to have wasted memory. The fixed header is something like this. Two point two. Flags. Remaining length. Starts at byte 2. Remaining length is the number of bytes. Remaining length is the number of bytes remaining within the current packet, including data in the variable header and the payload. The remaining length does not include the bytes used to encode remaining length. Size of remaining length field. Yes, it's not a simple bytes, they have encoded this also. Like size of remaining length field, 0 from this to this, digit 1, digit 2. Some MQTT header packet contains a variable header component. It resides between the fixed header and payload. The content of the let's just we can implement. We'll do this reading some other day, or if it is necessary only then we'll do the reading. Otherwise let's just go through this blog first. Like, who's going to read this? Like, that guy already did that. That's why he's writing this. Okay, so the control packet okay. So MQTT header will have MQTT connect will have a header. It's going to have a union of byte or bits. See, these are the things that is coming from somewhere that I don't know. That is why I just get sucked into this void of details. Now I want to know where these things are coming from. We'll do one thing. I'll suppress my urge to go into deep. She would agree. And we'll go through this block first. Okay, so this is like connect header. It contains some information like type of header, byte. So this is result. Clean session will QoS retain password user name unsigned. MQTT connect. There's just an indication that there is a password or not. Makes sense. Payload short. Okay. Short is 2 bytes. Unsigned short. It's like 2 bytes. MQTT connect. Don't tell me I'm going to implement every type of packet. Connect type, connect type, then every other type. From now on, the definition of the packets are trivial by reproducing the pattern according to the documentation. What the fuck, man? You are going to... I have to read the documentation. Oh, God. Oh. Oh. No, this feels like a burden. All right. डिसाइड किया है तो करना तो पड़ेगा गुरु. You don't fail, you give up. We never fail, we give up. This mouse is so bad, man. Giving me pain in my hand. The type named user type semantic separation. Man, I can't wait to finish this and then implement everything in Rust. Mqtt 2.0. Cool. Jonathan Blow said one thing. This kind of hit me. That everybody says that it is difficult to do it. And I'm paraphrasing, he wasn't actually saying this. He said, like, if you believe everyone else, what everyone else has been saying so far. And the example was operating systems. Everyone says that it is too difficult to implement an OS. And if you believe it, that yes, it is too difficult to implement an OS from scratch, then you are never going to do that. And you are coming kind of fresh. And in the initial days, you accept that yes, it is difficult to re-implement it, so I'm not gonna bother trying. Like, you failed on the day one, bro. Just because you believed it, that yes, what others are saying. I'm not saying that OS implementation from scratch is going to be easy. But you made it impossible for you to implement it by believing it. Yeah, it is, I think, in my opinion, it is better to give up in somewhere in the middle of the project instead of never starting it. Like, I would much rather fail implementing an OS from scratch rather than talking myself out of ever implementing it. Do you get what I'm saying? Anyways, okay, so we have to implement this Mqtt hack. I'll Mqtt connect. So divide P. ACK. So if by memory, I think it is going to header and a union of the byte, union of uint byte and struct of bits, which is session present unsigned. Unsigned is int by default, right? Unsigned session present, which is going to be of 1 byte, bit, sorry. RSERVT. You would say, why am I not copying instead of typing? Because why not? What is this RC thing? Boys, we are going to read documentation. Can't get away that easily. It's outside the union, right? Okay. Type Mqtt connect as MQTT comic. Cool. Now what is this? Unsigned int. About better. Remaining length. This is the length of a variable. For example, for con packet, this value is this has the value 2. Return code. Connect packet has no payload. Would it helpful? Fuck no. This is like too much load on the eyes. I can make it grayscale. Uh, yeah, Zapier is fine. Contrast. Brightness कम करो भाई तुम इसके. नहीं ब्राइटनेस कम करने से हेल्प मिल गई ना. Cool. You know what, a study suggested that dark actually strains your eyes and yellowish is much better, much easier on the eyes, I should say. Yeah. So I'm trying to find What I'm thinking. I want to know where these things came from. Con egg. This has a fixed header and a variable header is of as length value 2, which means connect acknowledge flag 3.9. What is 3.9? Figure 3.9. What am I, blind? तक man, बात का टाइम बिल्कुल ठीक नहीं भाई अपने लिए. This is Vega 3.9 and this is Vega 3.9. What the oh, man. Are you kidding, bro? So disappointed. So disappointed. Cool. Okay, so it has a fixed header which I just took care. Now it has this second byte thing. That's why that is why only 1 byte, 2 byte. Okay, I'm getting the hang of 2 byte. Makes sense. You want to access it via bits. Cool. So when okay, so if there are field names available, then you would want to define it as a union, because you just not only want to access it by their names but also by as a complete byte. Same thing. If it is the same thing, then you should define it as a union, otherwise don't bother. If they are mutually exclusive thing, either you would access that as a byte, access that as a or b. If a and b are mutually exclusive, then you can define them as union, because if a exists, b does not exist. If b exists, then a does not exist. Then it is fine to define them as union. Otherwise you can't. So, okay, so this is like acknowledgement flags, which has this value sp1 session present 1, and the rest is result. Cool. sp1 rest is result. Nice. And it is a complete 1 byte thing, right? Yeah. Acknowledgement flag. Byte 1 is the connect acknowledgement flag. It must be 0. It's a session present flag. Session present. What does the session present mean? So did he define it? Okay. Am I finished with this? RC. What was the RC? Connect return code. Byte 2 is headers. The value for the 1 byte unsigned connect return code fields are listed in table 1.4. This is a table 1.4. Don't even search for it. If a well-formed connect packet is received by the server. Okay, so if a well-formed connect packet is received by the server, client has sent a connect packet and server is able to receive it properly, but the server is unable to process it for some reason, then the server should attempt to send a connect packet, and this is interesting, packet containing the appropriate non-zero connect return code from this table. If a server sends a connect packet containing a non-zero code, it must then close the net. Okay. See, people have iterated over these things, so the protocol is just too good. Interesting. Very interesting. So just description. So the 0 means connection accepted. 1 means server does not support the level of MQTT protocol requested by the client. So server did receive it, but something was fishy there. Client identifier is correct, UTF-8, but not allowed by the server. Server has its kinks. Huh? Network connection has been made, but MQTT service is unavailable. Unavailable. I think my tongue is heavy for English. कैसे काटूं? The data in the server, the data in the username or password is malformed. Client is not authorized to connect, but reserved for future use. And this is giving me very good time. It has no payload, so we are good. See, this another behavior I just noticed about my brain, and most of us would agree, is this. I needed to know what this means, so I was supposed to read this, but my brain said nope, not right now, not yet. So it just said, let's just first do this because this is not relevant for now. After that, we'll return to this. It doesn't make any sense because I have to read this. But it is like, oh, this one is small, so I should read this first. Stupid brain, man. God forgot to give us a written manual with a binding that if you don't read this manual, you die on the spot. The moment you born, the God has to make some system like, if you are born, you born with a manual of brain. If you read this manual, only then you get to live. Otherwise, you don't go out there. Because understanding this fucking brain is so, man, so it just keep playing games, man. It just keep playing games. Like, I did not read this because it's too big. Let's just read this. Then we'll move on to this. What the fuck did brain achieve by doing this? There was some cognitive load, huh? So that's why. I don't know, I'm trying to understand this behavior. This intrinsic behavior. Okay, so the position bit 0 of the connect flag. Okay. The position of its position is bit 0. The acknowledgement flag. variable header. That was the variable header. This is mandatory. Every packet type has a mandatory header, but optional other header. So this packet has a header, has a variable header, but no payload. Does connect has payload? I mean, the guy has wrote it, so it must. So the fixed header is this. This value says some number. Variable header for connect packet consists of 4 fields in the following order: protocol name, protocol level, connect flags, keep alive. But they are not here. The remaining length is the length of variable header plus the length of payload. It is encoded in the manner described in section 233. Three one two. How did it implement that? Where these values came from, man? So you have a protocol name is a UTF-8 encoded string that represents the protocol name, which is uh, protocol level. Connect flags. I understand nothing. नॉन नॉर्मेटिव एग्जांपल क्या होता है? Variable header is 312. 312 name. Protocol level 7th byte.